Okay, 8.5b, elementary algebra, division of radicals. Let's continue on with this. We are on example number 6, and there it is. So let's go ahead and split these up. Now let's just look at the numerator here. Alright, do we know what the square root of 4 is? 2, so we can pull it out. Alright, okay, let's put that 2 back on there. Alright, remember our index is 2. How many times does 2 go into 3? Once, with 1 left over inside. How many times does 2 go into this 2? Once, with none inside. So we don't have any y's under the radical sign anymore. And we still have our square root of 3z on the bottom. Okay, so that's where we're at. Now what we're going to do is look and say, do we have this simplified? Yes. Do we have this simplified? Yes. But now we have to rationalize the denominator. So we're going to have to multiply top and bottom by what's on the denominator here. And in this case, it's the square root of 3z. So 2xy square root of x. I'm just rewriting it here. And I'm going to multiply the top and the bottom. And this ends up being 2xy, and then x times 3z. Remember, you can multiply anything, so that's going to go inside there. And that's going to be over that. And remember, because we multiplied that times that, this becomes squared, which means everything gets erased here except the 3z. So our final answer then is the 2xy on top, square root of 3xz all over 3z. Now, you cannot cancel this 3z with this 3z because this is not 3z. This is the square root of. Okay, so you can't cancel things inside here with things that are not in radicals there. All right, let's go to example 7. Alright, so notice the denominator here has two radicals separated by a minus sign. Now, earlier we had looked at something called a conjugate. Remember that? A conjugate is another expression that looks exactly like this, only the sign between them is the opposite. And one of the things that we learned about conjugates, especially with radicals, is that it gets rid of the radicals. Okay, so before we just had one radical in the bottom, like the square root of 3 over the square root of 5, and then we multiplied by the square root of 5 over the square root of 5, right? To get rid of the radical on the bottom. Well, now we have more than one radical, so what we're going to do is we're going to multiply by the conjugate. So we're going to multiply the top plus the square root of 2 over the square root of 3 plus the square root of 2. And again, what that does when I multiply those is it gets rid of the radicals. Okay, so when you multiply by a conjugate, if you remember, you square the first term, square the second term, put a minus sign there. Now I've got to multiply these two. So 3 times the square root of 3, 3 times the square root of 2. Okay, so that is where I'm at so far. Alright, so the square root of 3 squared is 3, plus the square root of 6. On the bottom, square root of 3 squared, the radical goes away. Square root of 2 squared, the radical goes away. So 3 plus the square root of 6 ends up being our answer. Okay, so here we are, example 8, and notice what we have here on the denominator. Two terms separated by a plus or a minus sign, so that means I'm going to multiply the top and bottom by the conjugate. 5 plus the square root of 3, so remember all you do is change the sign. Alright, so then we're going to distribute, because 2 is times each one of those. So 10 plus 2 square root of 3. Because whenever you multiply a number times a radical, you just stick them together. Alright, and bottom, since I'm doing it times a conjugate, I square the first term, put a minus, square the second term. And that gives me 10 plus 2 square root of 3 over 25 minus 3. Now if we look at our top here, do we have anything that's common that we can pull out? We have a 2 that we can pull out of the 10, and we have a 2 that we can pull right there. And one of the ways you can tell if you can do what you just did is if I distribute this 2 back in here, do I get this back? 2 times 5 is 10, 2 times square root of 3 is this. So yes, I get that back, so that means that's correct. Alright, now the reason I did that is I wanted to see if I could reduce that. And 2 over 22 reduces to 1 over 11. Or we can just get rid of that 1 there and just have 5 plus the square root of 3 over 11. Alright, so let's do number 9, and we're getting down to being about done with this lesson. So we have square root of a plus the square root of b over square root of a minus the square root of b. So again, we have no numbers here, but the rule always is the same. Times square root of a plus square root of b conjugate. Alright, so the easy part now is multiplying the bottom. Multiply the bottom and we get the square root. We square the first term minus square the second term. So that's pretty easy. But then we have to take square root of a plus square root of b times the square root of a plus the square root of b. So we have to do the FOIL method in that top there. Alright, so the denominator is just going to be a minus b. Ooh, I don't like that blue. Let's try a lighter blue. And then we do the FOIL. Square root of a squared outside inside and then last. Okay, so this becomes a. This becomes, how many of those do I have? I have 2 square root of ab's plus b over a minus b. And I'm happy with that. So that's example 9. Okay, so this is example 10a, cubed root of 2 over 3. So we're going to go ahead and split that up to the cubed root of 2 over the cubed root of 3. Okay, so now the question is, what do I multiply this by in order to get rid of the radical sign? Remember earlier, and I said that you're going to be going, oh yeah, I do remember he had mentioned this. I need to reduce this to the point where I need to multiply the top and bottom by something that when I multiply this times this, I get something like this. That's what I have to get. I have to get, remember I said you have to have your index and your exponents the same so that these go away. So I'm trying to get rid of the radical sign. So I need to multiply this times something in order to get this to be a cubed. Well, how do I get this to be a cubed? If I multiply it by, I can't get rid of that stupid circle I have there. Okay, so again, I'm trying to get this from my answer so that all this will go away. Okay, So I'm going to multiply it by the cubed root of 3 squared. Because watch what happens here. Whenever I multiply, what do you do with your exponents? If I have x squared times x to the 6, what do you do with your exponents? Okay, you add them. It's the same thing with the radicals. I've got a 1 here, right? And if I add it to this 2 here, I get my 3 right there. Correct? Yep. So I'm going to multiply the top and bottom by the cubed root of 3 squared, so that when I multiply these, I get this, which means that my radical goes away and just turns into 3. So, how am I going to multiply this? Cubed root of 2 times the cubed root of 3 squared. Or you can, instead of writing 3 squared, we can write it as the cubed root of 9. So the cubed root of 2 times the cubed root of 9 equals the cubed root of 18 over 3. Okay, does that make sense? This is probably one of the hardest things you'll do in math in this course, is to know what to multiply the top and bottom by. But if you remember that the index and your exponent have to be the same in order for all of it to disappear and just get a 3, then that'll help you to know what to multiply the top and bottom. So you're trying to find a number so that when you multiply it by this, you get this. And so sometimes it's a little bit tricky. So let's do another one, just so we can make sure we've got a little bit of practice doing this before I throw you to the wolves on your own. So let's do example number 10b, and we'll do that on the next video, and then we'll continue with going over some of the problem set. But I'm afraid I'm going to run out of room here if I don't stop now.